So to drill into this whole idea of isolation, we need to first see where we can get into trouble with isolation. There's 3 specific kinds of trouble we can find. The first is a dirty read. And a dirty read simply means that one transaction is able to see the update from another transaction before that update is committed. So in this diagram, transaction 1 has performed an update command, but has not yet committed that data. Transaction 2 comes along and performs a select, and it can see this update. And that is a dirty read. So let's see a dirty read inside a SQL Server. I've opened up the file, and we want to have 2 transactions or 2 sessions. So I'll say new query, and then set the second query to a second vertical tab group so we can see both side by side. And if I click on the first one, this is SPID or connection 51. The other one is connection 52, just to prove that these are different connections. And then here's the code for the second transaction, and I'm just going to move it over here. So remember, a dirty read is when one transaction makes an update, and before it's committed, the second transaction can see it. So our first session will start with the begin transaction, and this will create a logical transaction and hold the locks open for this update command until we do a commit transaction. So we'll execute this. It says 1 row affected, and transaction 2 comes over. We're doing the command set transaction isolation level to read uncommitted, and I'll explain isolation levels in a few minutes, but first I just want to show you the fault. So transaction 2 comes along and does a select, and it can see transaction fault, which was the update, back over here, even though we haven't done a commit yet. And that, my friends, is a dirty read transactional fault. Transactional fault number 2 is a non-repeatable read. What this means is that one transaction can do a read and then come back and do that same read and see different values, even though those values have been committed. So this kind of fault is called a non-repeatable read. In the diagram, transaction 2 does a select and sees certain values. Then transaction 1 comes along and does an update and commits that update, changing the values in that particular row. Transaction 2 comes back and selects that same row again and sees the committed change. And that kind of fault is called a non-repeatable read. It's just one other way that one transaction can affect a second transaction and violate isolation. So to see this inside a SQL Server, I've already set up Management Studio with a second query editor and moved transaction 2 over. If you're following along, you'll want to clear out the text in your second query editor window here, and then take transaction 2 and slide that over. And I'm doing it behind the scenes just to save time because we're going to be doing these same kind of 2-session transactions throughout most of this lesson. Okay, behind the scenes I've already set up Management Studio with our 2 query editors ready to show this transaction fault. And we'll begin by setting the transaction isolation level for transaction 2 to read committed. And then within a transaction, it'll select the nickname from customer 1, and we just set that to transaction fault a few minutes ago. This transaction is still open, so if there's perfect isolation between them, this update should not be seen by transaction 2. Now, it's just an update right here, so we're not doing a begin transaction, commit transaction right away. It's being updated. So execute this, and if we come back, and we're still within a transaction here, do the select, and we see the non-repeatable read error. And that's transaction fault number 2, the non-repeatable read. The third type of transactional fault is a phantom row. And what will happen in a phantom row is that one transaction can see another transaction's new rows. And the phantom row could either be a new row that is inserted or maybe a value changed, so that now that row shows up in the where clause. Looking at the diagram, Transaction 2 does a select with a where clause and gets back a certain number of rows. Transaction 1 does some type of update or insert which would affect that same row set that Transaction 2 just inserted. And then when Transaction 2 does another select with the same where clause, it sees that committed new row show up, and that's called a phantom row. I've already set up Management Studio to show you a phantom row. So in Transaction 2, and I'll talk about setting the isolation transaction level in just a couple minutes here. We're already in the right database. So Transaction 2 is going to go ahead and select all the customers where the nickname is Missy, and it sees one person there. Another transaction comes along and changes another row so it also has a nickname of Missy, which is the same where clause condition by transaction number 2. One row affected. Now we're still within the same transaction because we ran a begin transaction. So if we do the select again, we now see a second row come up. This is customer ID 3. Debbie has the same nickname, Missy, and shows up as a phantom row. And this demonstrates the phantom row transactional fault. So we've seen the 3 different types of transactional faults: dirty read, non-repeatable read, and phantom row. And the isolation level, or the fence that's in between 2 transactions, can be adjusted to permit or to block these different isolation levels depending upon how strict you want to be in your isolation. At the lowest level, if you set the isolation level as low as it can go to read uncommitted, then basically you're not going to enforce any isolation between 2 different transactions, and they can see each other's non-committed changes. So that's the read uncommitted isolation level, which is the same thing as setting a hint called with no locks. Read committed is the default behavior for SQL Server. So if you don't make any changes to your isolation level, you will at least make sure that you can only see committed changes, but you will allow non-repeatable reads and phantom rows. And for 99 times out of 100, that is the most appropriate isolation level. But you can set the isolation level higher to repeatable read or to serializable if you need to. There's going to be a real performance hit with repeatable read or serializable, because with one exception, the way the isolation works is with locks. And when we talk about locks in a few minutes, you'll see that the duration of the lock is determined by the isolation level.